Lesson 13.1, Task 1. So there's a lot of definitions in this section, so make sure that you get these definitions as we go through this first part. All right, it says define a mathematical sequence. When you do things in sequence, you do them in order, first, second, third, and so on. A sequence is an ordered list of numbers, each number a term of the sequence. Because a sequence maps a set of ordered integers to the terms of the sequence, a sequence is a function whose domain is a subset of the integers and whose range is the set of values of the terms. A sequence is often described by an equation or a rule. The domain for the rule often begins with the position number n equals 1, though it doesn't have to. Consider the sequence A of n describing the cubes of the first 5 positive integers. All right, so A of n equals n to the third. That's what it means to cube something to the third power. So the domain for the first 5 positive integers would be 1, 2, 3, 4, 5. Your range would be those 5 numbers cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. Because A of n is a limited number of terms, it is a finite sequence. Extending the domain of A of n to all positive integers, 1, 2, 3, 4, 5, ... and you know the ... means it continues, would give an infinite sequence. So that means the range would also have a ... to show that it's infinite. You can describe a sequence using function notation or subscript notation. Function notation, A of n equals n to the third. So your first term is 1, your second term is 8, your third term is 27, and so on. Subscript notation, so it should be A sub n. This should be smaller than the A. I guess when they typed it, they didn't know how to make the subscript on here, or maybe it just didn't have it. But these numbers, like this number, should be an exponent. It's a small number higher than the regular numbers. This subscript should be a small number, and it should sit beneath everything else. Okay, so A sub 1 is 1, A sub 2 is 8, A sub 3 is 27, and so on. All right, so it gives us a picture, and it says the diagram shows the seating patterns for a theater. The number of seats in nth row, where n is greater than or equal to 1, can be described by a sequence with the rules shown using both function and subscript notation. So you can see in the theater there are 14 rows. N represents the number of rows. The first row has 11 seats in it. All right, so A of n equals 11, that's your first term, plus 3 times n minus 1, or A sub n equals 11 plus 3 times n minus 1. So this is function notation, and this is supposed to be subscript notation. All right, so this is complete the partial table for values of A of n. All right, so 11 plus 3 times 0, if I plug 1 in for the first term, 1 minus 1 is 0, 0 times 3 is 0, so the first term is 11, which the image above showed that the first row had 11 seats in it. And then 2 minus 1 is 1, 1 times 3 is 3, 3 and 11 give me 14, and I continue that pattern by adding 3 each time to get to the next term. All right, and you can check it by substituting 5. 5 minus 1 is 4. 4 times 3 is 12. 12 plus 11 is 23. Okay, so it says the domain of the sequence is 1 through 14. That's because there's 14 rows in the theater. So what is the range? The range would be 11, 14, 17, 20, 23, and then ... whatever 14, whatever you plug in to get 14. So let's see. 14 minus 1 is 13. 13 times 3 is 39. 39 and 11 give you 50. So we would be these terms, and then ... comma, 50 would be the last number in the range. All right, so it says what numbers in the rule represents the seats in the diagram? There are blank seats in the first row. All right, if you go back to the diagram or the table, either one, you can see that there are 11 seats in the first row. And there is an increase of 3 seats per row. All right, it says the graph shows the first 10 terms of the sequence. Could you show the graph of the entire sequence? Explain. All right, so this says row, so there's 10 rows shown, and it goes up through 40 seats. So you could expand this out to 14, because we know there's 14 rows, and then expand this up to 50, because 50 was the biggest number. So it says it doesn't go on forever, but it does go up to n equals 14 rows and 50 seats. So that would be the correct answer for C part. All right, so that is all for task 1. If you have any questions, please let me know.